Hello and welcome to Grody UnPrOfEsSiOnAL. My name is Justin McMenamy, and my mission is to share both profitable and painful leadership lessons acquired over a 20-year career as a misfit in corporate America. In this episode, we discuss everything from the costly pursuit of perfection to the orbital mechanics of hairballs headed down the drain. In the book Orbiting the Giant Hairball, author Gordon MacKenzie shares a treasure trove of experiences amassed during a 30-year career within the greeting card giant Hallmark. MacKenzie spent much of his career within a division called Contemporary Design, a group described as the crazy aunt of the family, known for shirking policy, procedure, compliance, and rigidity. Employees within this countercultural division were described as renegades, known for resisting top-down directives. Unlike the rest of Hallmark, employees within Contemporary Design were rewarded for originality, rule-breaking, nonconformity, and experimentation. To outsiders, Contemporary Design had been given over to chaos. The proverbial black sheep, inexplicably allowed to exist inside a tried and true blue-chip company. One may ask why a leader like MacKenzie and a group like Contemporary Design was allowed to rebel. MacKenzie explains that this countercultural chaos continually generated exceptional profits, making it untouchable by stiff-shirted executives. A key observation and the inspiration for the book's title is captured in the word picture of a creative, countercultural satellite orbiting a stable, largely static mothership. MacKenzie concludes that being proximal to, but not entangled with, an established business can be a fertile environment for sustained creativity and innovation. Modern startups often believe industry disruption can only be attained in the complete autonomy of deep space, outside of the gravitational fields of existing market players. MacKenzie's counterpoint is that deep space introduces as many problems as it supposedly solves. While an autonomous startup may not be influenced by the gravitational forces of a larger company, its celestial trajectory is very much influenced by the availability of capital, or more subtly, by strings attached to capital raised. Conversely, hoping to foster creativity and disruption within the rule sets and constructs of large, established organizations proves even more inhospitable than deep space. MacKenzie coins the term corporate normalcy as the intricate patterns of effective behavior down-selected over years which leads to success for the individual and for the company. Corporate normalcy always becomes a paradox. It is simultaneously a key component of continued success according to the past way of doing things, and an almost insurmountable barrier to exploring and discovering opportunities or new forms of success in an evolving marketplace. Considering the perils of deep space and the near impossibility of exploration in the highly regulated hairball of corporate normalcy, MacKenzie offers the theory that if a renegade countercultural organization were allowed to orbit the larger corporate body, there may be the right mixture of stability and freedom to facilitate the exploration, discovery, and creation processes. A satellite organization, if able to maintain geosynchronous orbit, benefits from the predictability and order of the larger organization's gravitational field, yet retains many of the degrees of freedom afforded in deep space. About now, it is logical for you to ask the question, why are we talking about Gordon MacKenzie and Hallmark in an episode entitled Skunk Works? I signed up for SR71, and you are discussing precious moments. During my decade as an executive at a small, fast-paced, disruptive organization, I and a cadre of leaders took on the personal and professional challenge of maintaining the startup culture of our company, Precision Planting. despite being owned by larger established companies steeped in corporate normalcy. Books like Orbiting the Giant Hairball, in concert with resources like Kelly Johnson's 14 Rules of Management, were instrumental in articulating and visualizing the mechanics at play when trying to sew creativity and structure into a single organizational mission. While this mini-series primarily focuses on my experiences through the lens of Kelly Johnson's 14 Rules of Management, it would be short of accurate to exclude the contributions of Gordon MacKenzie to our cause and our success. Welcome to the fourth installment of my survey of Kelly Johnson's 14 Rules of Management. In the last episode, we discussed a minimum necessary approach to processes like budgeting, purchasing, and the use of metrics. In this episode, we continue our march by discussing how a semi-autonomous renegade organization can differentiate itself from corporate normalcy on topics like continuous improvement, the data fallacy, and the flow of information through the value chain. Kelly Johnson's 8th rule of management is push basic inspection responsibility to subcontractors and vendors. Don't duplicate inspection. Early in a company's life, decisions are often made by the seat of the pants. Often the rapidity of decisions is rooted in the lack of time, but more frequently, rapid decisions are the result of a curated instinct within the decision maker, refined by years on the front lines. Leaders in small, rapidly evolving companies often don't request reams of data from their staff because they have been in the industry for years and they know the customer well. However, as organizations grow, shooting from the hip decision-making is cast as immature or inefficient as professional managers displace well-connected early leaders. During this transition, a leadership mindset emerges, which states more data is always good. This mindset finds fertile soil in the pain of previous missteps, cast in a light which concludes haste or misguided intuition was to blame. Fact-based decisions are positioned as professional or strategic, while previous mindsets are labeled pragmatic or reactive. The professional manager believes a business can be summarized and optimized through a curated set of metrics. Therefore, a critical means of improving the business is to increase the percentage of the business processes represented in numbers. One observation from my career: most often the conversation which presses for more data is always better takes place in the sterility of a conference room, somewhere between hundreds of feet and hundreds of miles from the reality which the leader hopes to measure. Time and time again, these decisions are made based on abstract anecdotes like what gets measured gets managed, or a theoretical future in which we will be glad we have this data. My preference has been meetings in which a new inspection, a new measurement, or a new metric is being proposed should be held in the environment in which the data will be collected, with the people that will be tasked in perpetuity to collect and curate the information. Even within our smallish $450 million company, comprised of 400 employees, there were undoubtedly tens of thousands of hours spent by employees inspecting, measuring, re-inspecting, and remeasuring many aspects of our business, creating reams of data largely left unsearched, but defended by the logical fortress of it will be nice to have if we ever need it. As with previous discussions of budgeting and metrics reporting, I am not arguing that all measurements and data collection should be removed from an organization. I am merely saying the rainy day logic of collecting new data should not be undefeated at the conference table. True costs of collecting, collating, and storing engineering, manufacturing, or business data are largely hidden and often unconsidered. While this mindset pervades all departments, I am most familiar with its manifestation within engineering and manufacturing. It is often far too easy for a design engineer to formulate a manufacturing inspection plan under heavy influence of risk avoidance, as opposed to considering the balance of risk and cost to the business. Meaning, the costs of poor quality are often plainly obvious and personally painful. For the business, there could be increased rework in the factory, delays in product delivery, or warranty issues in the field. For the individual, there could be late nights working through urgent issues under the scrutiny of leadership. On the contrary, the costs of inspection, and particularly reinspection, are often hidden and nearly impossible to remove once they have been initiated. If an organization is not careful, there will be constant ballooning of costs and effort placed on ensuring perfection in the product. The point that Kelly Johnson makes with this rule is that inspection and measurement should take place as early as possible in a given process, should not be repeated, and should be balanced against the costs incurred. I can hear the naysayers. Justin, are you advocating for poor quality? That is grody and unprofessional. I'll let my friend Ben Rich, longtime director of Skunk Works, address your concerns. In the book entitled Skunk Works, he writes, "We cannot enjoy total product perfection and really don't need it." This quote is amazing. Mr. Rich is talking about precision military weapon systems designed to fly faster than the speed of sound. Who are we to think that our terrestrial widget, traveling no faster than a UPS truck, requires product perfection and absolute assurance of performance? The costs, whether hidden or not, are simply too high. Kelly Johnson's 9th rule of management focuses on the importance of creating environments where the person responsible for producing an outcome has access to the environment in which their work is being deployed. The 9th rule states the contractor must be delegated the authority to test his final product in flight. He can and must test it in the initial stages. If he doesn't, he rapidly loses his competency to design other vehicles. Much like the previous rule, it is important to highlight that while the 9th rule is most directly written to ensure engineers can test their products in production environments, the same principle applies to every discipline within an organization which aspires to maintain speed and agility in a dynamic environment. Growing organizations face increasing temptation to specialize employee roles. In engineering, it could be the separation of design, test, and manufacturing roles. Within marketing, it may be the separation of creative and tactical marketing. Other examples include the formation of a strategy group or a business intelligence group tasked with surveying the marketplace for emerging trends or opportunities. To be clear, specialization alone is not a problem. I was a cautious advocate for targeted specialization within our business as we grew rapidly. However, with specialization, there is a natural undertow which thrusts some roles forward towards the front lines, while other roles are pulled away from the action. Rule 9 applies equally across the business. The designer of the program, strategy, product, or initiative must directly and regularly participate in deployment. The feedback loop must be in person. It must be experiential. It must be unfiltered. Otherwise, the temptation is too great for the thinkers to cast blame on the doers for ideas destined to fail from conception. Kelly Johnson's call for employees to have access to the front lines, where ideas interact with reality, reminds me of a set of parallel experiences collected inside two starkly different product organizations. The first experience came as a product improvement engineer within a large, world-class organization. The second experience, informed by the first, came during my tenure as an engineering leader within Precision Planting. At issue was the administration of continuous improvement initiatives in response to product issues in the field. As a design engineer within a large multinational mining equipment company, I was annually provided a spreadsheet summarizing all warranty claims for parts under my design control. In addition, we were assigned the goal of reducing warranty expenses by 30%. During my first year in the role, upon receiving both the spreadsheet and the goal, I asked my supervisor what additional information was available to aid in my improvement pursuits. Are there failed parts I could look at? Unfortunately not. Most of the parts are big and the customers are spread out all across the globe. Okay, is it possible to speak to the technician that serviced the failed parts? No, not really. As a habit, the organization prefers not to have design engineers talk with dealer technicians. That's really the job of the service engineering team. See, if a design engineer called a dealer, it may give the impression that there is a systemic problem, and the dealer may lose confidence in the product and stop selling it. Okay, so I'm guessing talking to the customer is out of the question. Yeah, in general, the sales team at the dealer interacts with the customer. There really isn't a mechanism for an engineer to talk to a customer about a specific issue. See, our products are world-class. They don't have issues. And when they do, we solve them quickly. So you should get to work. Oh, wait, actually, there is one thing. If you want to look for more information, you could read the warranty claims entered by the dealership when they filed for reimbursement. After 3 days of waiting for access to the warranty claims database and 15 minutes of looking through them, it was clear the information in the forms was at best loosely correlated to reality. To prevent dealers from overclaiming warranty work, our company regularly audited the claims forms, often denying warranty reimbursement requests which were deemed outside of the warranty policy. This set up a game of cat and mouse. The dealer, through trial and error, learned the claim descriptions, which most often led to a warranty payout, leading to dozens of claims being literal word-for-word copies of one another, misspellings and all. As an engineer, I was looking for any insight into what may have caused these issues, in hopes of diagnosing the problem and in hopes of solving them. But the information provided was choppy, vague explanations tailored to pass audit more than to convey information. Needless to say, I was almost completely unsuccessful at reducing warranty on the components in my design control. While engineers may be smart, they are not able to learn from and improve upon that which they cannot see or touch. One brief side story. The single largest warranty issue on the machine under my design control was the exhaust pipe. For some reason, every exhaust pipe failure occurred when the machine was brand new, even before it had been delivered to the customer. After several phone calls, some of them approved and some of them covert, I was able to piece together the story. The machines were delivered by train, and on certain routes, the exhaust pipe, which is the highest point on the machine, was being knocked off, most likely by specific overpasses. When this happened, the machine arrived at the dealer without an exhaust stack. You would think this should be a straightforward fix. That is, until you discover that the department tasked with fixing the problem was different than the department required to make the change. The result was the often experienced but rarely resolved corporate stalemate of dueling departmental metrics and motivations. I left that role 14 years ago. I can only imagine to this day there is a train overpass somewhere in the American Southeast amassing an ever-increasing mountain of smashed-up exhaust pipes. Shortly after joining Precision Planting, we launched a product which stretched every aspect of our business. While the product drove significant growth, that first year we were swamped by our success, including several product warranty issues. Like at my previous employer, I asked if it was possible to see the failed parts, hoping to increase our chances at finding the root cause of the failures. I was told that the parts were returned from the field, but it was unclear what happened to them once they returned. So I went to their last known whereabouts, the receiving department, and I introduced myself. I asked where the warranty return parts ended up after they were received. The receiving team looked at me like I was from another planet. They said, "You are the first person to ever ask that question. For years, we have been unsure what to do with the parts, so we keep them on the receiving dock until they fill up a pallet, then we put them in the dumpster." I thanked them for their attention to detail and for storing them as long as they did, and then asked for a simple change to the process. Rather than placing the pallet in the dumpster, please send it to the engineering department. They were overjoyed at the request. Not because we were taking something off their plate. They were excited that their efforts to receive the parts would now be used beyond simply filling dumpsters. Upon returning to the engineering department, I shared that all field return parts would now be arriving once a week. I then made a simple request. Out of politeness for the engineering shop manager, each engineer should find and remove parts under their design control from the shipping dock. I want to suspend the story for a moment to highlight a few things that I did not do. I did not create a warranty reduction goal for each engineer. I did not place warranty reduction on a monthly metrics one-sheeter. I simply asked design engineers to help their neighbor by keeping the dock clear of parts that they had designed, which happened to be sent back because someone felt that the parts weren't doing the job that they had been purchased for. Having been a design engineer myself, I knew this request placed a temptation too great in front of the high ownership engineers in our organization. When an engineer designs a product, they garner parental feelings for that product. As proof, if you ever get a chance, walk amongst a group of engineers' desks and compare the number of parts on their desk with the number of family photos. I think you'll be surprised. I knew it would be impossible for an engineer to uninterestedly hold a part they designed, which had been accused by someone else of not working. No metric is needed. No motivation is needed beyond the motivation of the engineer to better understand and improve their design. The simple change of bringing broken parts home categorically increased the design engineer's ability and motivation to understand and ultimately solve product issues. There is one caution to keep an eye out as a manager seeking to harness the ownership emotion of a design engineer. Engineers are tempted to justify product failures as being caused by others in the value stream. The person that broke the part either didn't correctly care for or understand the use of the product. Once an engineer feels that improper manufacturing, installation, or operation is to blame, the engineer will be tempted to wash their hands of the issue, expecting instead that the true culprit must clean up their own mess. The temptation here is to accuse the marketing team, product management, the sales team, the customer, the supplier, the manufacturer, the assembler, or the dealer technician of ignorance or even malfeasance. This blame shifting is an unsightly reality of many engineering organizations, and it must be addressed by engineering leadership. It is also worth us, for a moment, stepping out of this specific example and reminding ourselves that this temptation exists in all employees. It is easy to create a logical scapegoat for failure by blaming others. A goal of a leader in this situation is to remove those excuses by placing the employee in the position to not only diagnose the root cause, but be part of the solution. Now, back to our story already in progress. To prevent this often used accountability escape, I reframed the conversation with our engineering team. Each failed part in the box represents an event in a customer's life in which they were using our product to perform their livelihood, planting a crop in our instance. For some reason, the customer stopped what he was doing, believing something was wrong, believing he was limited in his ability to perform the job he paid us to help him with. For right or for wrong, a combination of the customer and the dealer selected this part as the most likely component that hindered them in their work. We may find in our investigation that the dealer swapped the wrong part. It may be that the customer had unreasonable expectations about what the component was capable of. It may be that our diagnostics erroneously pointed to this part being the problem. It may be that in the heat of the battle, the stump dealer needed to show the customer he was trying something. And in the ensuing game of swapnostics, this is the easiest part to swap. In each of these instances, the design of the component is not directly to blame, and the return part may still function perfectly. But every part in the bin represents a scenario in which a customer trusted us to aid them in the completion of a task. They had to stop that task, and they believed that this part was the cause. Your job as the chief investigator and designer of the part is not merely to prove the innocence or guilt of the engineering that went into the part. Your job is to diagnose what led the customer or the dealer to believe this part was preventing them from completing their work and help us implement the changes necessary to reduce the frequency of this event. By reframing a warranty problem in this light, you will absolutely pull at the emotional heartstrings of typically stoic engineers. All of this is a waste if the rest of the company is not on board with a holistic approach to solving warranty problems. If an organization can cooperate in the pursuit of understanding causes of unmet customer expectations and collectively seek the most effective solutions among each of the departments, the universe of solutions to warranty problems expands categorically. No longer is the engineering print the only place warranty problems are solved. Now the organization can look for means of reducing warranty in dealer training, assembly instructions, packaging, diagnostics tools, in-season support, and even product positioning by the sales team. Most large, metrics-conflicted organizations expect a foolproof design from engineering, which can be manufactured, assembled, sold, installed, operated, and serviced in a vacuum. It is a wonderful scenario when a foolproof solution is both attainable and cost-effective. However, in many instances, a company's demand for a foolproof engineering solution results in the company passing over much more cost and time-effective solutions. We had a specific instance in which the second highest warranty issue in our company was all but eradicated by retooling dealer training. Engineering and support worked together to create a memorable and impactful teaching point for a specific step in the installation process. By addressing the issue through dealer installation training, the company saved millions of dollars in product redesign, field validation, and inventory obsolescence. Over the years, we made small updates to the warranty return program, aimed at further improving communication among engineers, dealers, and customers. Within any given pile of warranty return parts, there are always several of them that do not seem to have any problems. Nothing looks to be physically broken, and the parts pass the battery of performance and validation tests aimed at simulating real-world usage. This group of parts is often called no fault found, meaning the engineer has inspected and tested the part and is unable to reproduce the problem. Often, no fault found parts are a source of contention. The business is tempted to believe dealers are gaming the warranty system. Dealers feel that the company is questioning their capabilities and business practices, and engineers feel that they are improperly being blamed for flaws which do not exist in their designs. Rather than being trapped in the same finger-pointing game many companies find themselves in, we saw an opportunity to press even more into collaborative problem solving, to press even farther into getting as much information to the engineer as possible in hopes of solving the problems. For products which had unusually high no-fault found returns, I asked the dealer network to include a toe tag with the return part. I told them, unlike my previous organization, the information on the toe tag would have no bearing on the processing of the warranty claim. The information would be used by the engineer in their pursuit of solving the puzzle of what went wrong. I asked them to write anything they thought relevant to the failure. Was it raining that day? Was it particularly hot that day? Did you have a ham sandwich for lunch instead of roast beef? Anything they thought might be the reason we wanted to hear about it. I told them there was a real possibility an engineer would call them if we thought a follow-up conversation could help us better understand the issues. I was leading with transparency, humility, and candor. I was asking for collaboration in pursuit of a shared benefit. Years after implementing the toe tag system, I never once heard from a dealer frustrated by a call from an engineer. Even young engineers that brought with them 10 times more questions than answers. On the contrary, I regularly heard from appreciative dealers that an engineer was trying to solve their problem, and they were thankful that their experiences were considered in the pursuit of the solution. Why a toe tag, you ask? As a small ragtag company experiencing rapid growth, our problems in many instances grew faster than our structure. Any business experiencing rapid growth is exposed to this and therefore needs to be creative. At the time, we didn't have the systems in place to electronically track the stories along with the parts. Therefore, simple, wired toe tags from Staples are how we started. We next modified our process by implementing an annual opportunity for engineers to show off to their coworkers the problems they found and resolved amongst the warranty parts. Please take special note of that previous sentence. I'll repeat. An opportunity for engineers to show off to their peers and coworkers. This is very different than a design review. This is very different than an engineering change management approval board. In fact, leadership was largely silent in these meetings outside of showing appreciation and support for the hard work and earnest investigation into some of the most difficult technical challenges we faced within the current product line. We later took the logical but almost never taken step of having those same engineers present to dealers on the warranty investigations and resulting quality improvements. In most companies, this meeting would be strictly forbidden. Out of fear, a meeting of this nature could expose the company to litigation, dealer demands for field updates, or reduced motivation to continue selling the current version of the product until improvements are implemented. These risks are real and must be calculated. To be clear, each situation was unique. We did not present on all updates. I understand there are a lot of nuances in these conversations, but I also understand that a company holding a talk track of nothing to see here in plain sight of a significant problem creates enmity, strife, and mistrust, ultimately fraying, if not severing, the relationship lines needed for the fastest means of solving the problem. Rarely do organizations get sued by customers and dealers that have been working honestly and collaboratively with one another. I have, however, seen a number of lawsuits from customers and dealers that feel they are being stonewalled by the company. Circling back to the metrics and visibility conversation around Kelly Johnson's 5th rule, there was very limited visibility or top-down enforcement of any of the processes we've been discussing. My goal was to inspire and equip engineers to pursue improvement. Rather than focusing on the creation and enforcement of metrics, I focused on changing the temperature of the room, changing the ingredients in the culture such that engineers were naturally motivated, rewarded, and fulfilled in pursuit of the right actions. Over the course of 2 or 3 years, we saw, through the advent of this simple structure, a 90% reduction in unit warranty paid on the highest volume product lines. Over the decade, our organization launched 20 additional products, during which the business quadrupled, while the total warranty expense remained flat or decreased. Growing organizations face specialization challenges, communication challenges, scaling challenges. Kelly Johnson's point in the 9th rule is that the solutions to those challenges should not include the separation of the thinking class from the front lines, should not include the segregation of the thinking class from the doing class. All employees must be required to spend time implementing their own ideas, eating their own dog food, as the phrase goes. Otherwise, as Johnson says, employees will rapidly lose competency to design other vehicles. For those that wish to share comments, praises, or large sums of money, or simply to show the G.I. Joe spirit, you can reach me at justin@grody.io. For those with complaints, concerns, frustrations, or accusations, you can reach me by sending a self-addressed stamped envelope to Knowing is Half the Battle, P.O. Box Not Real, Pawtucket, Rhode Island, 02862. To ensure prompt reply, please include 25 G.I. Joe proof of purchase flag points. Thanks for your time. Let's do it again soon.